Hey guys, so today we have our triangle ABC, where AB is 2, AC is 3 root 3, and angle A is 50 degrees. We know X is going to be somewhere on AB, Y is going to be somewhere on AC, and we have to position X and Y somewhere on these two sides such that we can get the minimum possible value of the sum BY plus XY plus CX. So the way we're going to go about this problem is we're going to reflect this triangle ABC over both sides AB and AC. And so we're going to reflect it over AC first, and that's going to give us a triangle like this. I'm going to call this B prime. Then we're also going to reflect the triangle over side AB. That's going to look something like this. And right there. Okay, we're going to call this C prime. So what is the shortest distance from one point to another? It's going to be a straight line, right? So I'm going to draw a straight line from B prime to C prime. Close enough. Okay, so what does this line from B prime to C prime actually represent? Well, how about we reflect parts of the line back into the triangle? So what I'm going to do is I'm going to reflect this triangle AB prime C back onto ABC. So that means all the side lengths go on. This little segment will go from this point, go back to B. Right there. Okay. Next, I'm going to reflect this triangle with C prime back onto C. This line segment stays, but this line segment right here will go back on to point C. Okay. Now we've established that the shortest distance from B prime to C prime is a straight line. But also look at what we've done. We've also managed to find our points X and Y, because if this is the shortest distance from B prime to C prime, this is one line segment right here. But we've reflected this portion of the line segment onto point B, so this is the same length as this segment, and this segment is the same length as this segment because we just reflected it over. So the sum of these three segments, 1, 2, and 3, is the same as this one segment from B prime to C prime. So by doing this, we've actually found out our points X and Y that minimize this sum. All we need to do is now find the sum of the three line segments. But since we've established that these three line segments, the sum of this is the same as the numerical value from B prime to C prime of that distance, all we need to do is find the distance from B prime to C prime. And we can do that. We know that AB is 2, and since we reflected it over, AB prime is going to be 2. And since we reflected AC onto AC prime, we know AC prime will be 3 root 3. We're also given that angle A is 50 degrees, and since we just reflected the triangle twice, we know these angles will also be 50 degrees. So this angle is going to be 150 degrees. From here, we can just use law of cosines to find B prime C prime. So I'm going to call this distance from B prime to C prime X. So we have X squared equals 3 square root of 3 squared plus 2 squared minus 2 times 3 root 3 cosine 150 degrees. And simplifying this, we get X squared is 27 plus 4 minus 12 root 3. Cosine of 150 degrees is negative root 3 over 2. We have X squared equals 27 plus 4. Negative cancels. 12 root 3 times root 3 over 2 is 18. And we have X squared equals 49, or X equals 7. So 7 is our answer to the problem.